So hi everyone and welcome to this how-to video on LS-Opt. In this video I'm going to show you how to set up an optimization using PRIMER Morphing. I'm going to start with an existing project and add a primer pre-processing stage to it in order to apply the morphing. So let's go and have a look at the project first of all. Okay, so this is the project that I'm going to start from. I'll explain a little bit more about this project in a moment, but first let's take a look at the model. So I'm going to go into the LS-DYNA stage and we can see that we've got a model defined here. I'm just going to browse to the directory of that model and then open it in Primer. Okay. So it's a simple submodel of a crush tube, which is an energy absorbing device at the front of a vehicle. The crush tube itself is made up of two parts, the green and red parts, which are fixed together by several spot welds, which you can see by the pink blobs. The blue part at the end, that attaches to the back of the bumper, and that's there to stabilize the crush tube as it deforms during an impact. So let's take a quick look at the baseline crush tube behavior in D3 plot. So I'm just going to drag the PTF file into D3 plot. Okay, and if I hit play, I'm just going to slow that down a little bit. And we can see the crush tube deforming. So the crush tube impacts the blue component, which in this submodel is fixed in space, and the impact velocity is 30 miles per hour. So I'm going to go back to LS-Opt now and have a look at the rest of the optimization. I'll just close down these windows. So we'll take a look at the optimization stage first of all. And we can see that the optimization objective is IE sum. That's the internal energy sum of the crush tube components, or the absorbed energy of the crush tube components. And we can see here that we're trying to maximize this. We're trying to maximize it subject to some constraints, and they are constraints on the amount of crush, so the crush displacement, and also the peak contact force between the crush can and the blue component, which is at the end of the bumper. Both of these are negative values because in the analysis they are negative, so I've set lower bound constraints on those responses. If we now take a look at the variables in this optimization, so I'll go to the setup stage, we can see that we have two variables, inner T and outer T, and they are the thicknesses of the two crush can components. So what we're trying to do is find the optimum set of thicknesses that maximizes the absorbed energy of the crush can. So that's the starting point, but what we're going to do is add some more variables, and these are going to be used to vary the shape of the crush tube, and we're going to do that via primer morphing. So I'm now going to go back into Primer and set up the morphing operations, which LS-Opt will use. Okay, so back in Primer, if I go to the top right and go into Mesh Tools and Morph to open up Primer Morphing, the first thing I need to do is define a morph box, and I'm going to include everything in this box. So I'm going to select nodes and just drag a box over everything in the model and click Create Box. Okay, now we're going to set up the morphing operations. For the first, I'm going to apply some taper to one side of the crush tube. To do this, I'm going to select an edge at the front of the morphing box and drag it in X. So I'll select this edge and drag it in X. And we can see that that has applied some taper to the crush tube. With the morph applied, I need to store it as a morph flow, and that's done by going to the Variables tab and giving the flow a name. So I'm going to call this outer taper and hit Create like so. And we can see now that arrows are drawn on the morph box to show that a flow is defined. Next, I'm going to apply some taper to the other side of the crush tube, but before I do this, I'm going to reset the first flow via the Utilities tab. So into Utilities, select the morph box and reset it to return to the original shape. If I didn't do this, then the next flow I create will include the first morph, which is not what I want. I want the two tapers to be applied separately. So now I can set up the second taper on the other side, just as I did the first. So I'm going to select the other edge and drag that in X, like so. And I'm going to save that as a morph flow again, and this time I'm going to call it inner taper. And hit create. It's worth pointing out that the amount of morphing I'm applying at this stage doesn't really matter, because ultimately LS-Opt is going to decide how much morphing to apply. At the moment, with these morph flows, we're really just defining the morph directions. Okay, so that's all the morphing that I'm going to apply. I'm going to reset the box again to return to the original shape. And now I need to save the morph flows to a file, which LS-Opt will read and use to apply the morphing. So I go back into the Variables tab, and underneath Variables file, I just need to give this a file name. I'm going to call it dv.text, dv standing for design variables, and I'm just going to write that out now. And I also need to save the model with the morph definitions in it. So I'm going to go to Model and Write. I'm just going to change the model name. I'm just going to add morphing to the end of the model name. Okay, and hit apply like so. Okay, now let's take a look at the variables file in a text editor. So I'm going to open up the text file, the dv.text file. Here we can see the two morph flow definitions, outer taper and inner taper. The value parameter for both of those flows is currently set to 0 because we reset the morphs after creating the flows. And we're going to get LS-Opt to substitute those values to vary the amount of taper applied. To do that, I need to replace those zeros with LS-Opt parameters, and the format is to place the parameter names in between double greater than and less than symbols. So let's do that now. So outer taper, and the inner taper, like so. And once I've done that, LS-Opt will now recognize those parameters and substitute them during the optimization. So I can now save this file and close it. Now we're going to go into LS-Opt and set up the primer stage. Okay, so to add a new stage, we need to click the Add button at the top of LS-Opt, Add Stage, and in the current sampling regime. I'm going to call this Primer and click OK. LS-Opt has defaulted to running this primer stage in parallel with the LS-DYNA stage, but this isn't the behavior that I want. I want primer to run first of all and then pass the pre-processed model into the DYNA stage, so I want them to be in series rather than in parallel. So I can adjust the workflow by simply dragging and dropping the arrow from the primer stage into the DYNA stage, like so. And now those two stages are in series. And I'll just tidy up the schema a little bit by moving that stage across. So let's go into the primer stage now. Okay, and we can see that it has defaulted to being an LS-DYNA stage. I'm going to change this to a user-defined stage. Now at the moment, Primer isn't included as one of the standard packages in LS-Opt, but we're hoping it will be added in the next software release. But for now, we can add a Primer stage via the user-defined stage. Okay, so the first thing I'm going to select is the input file, and this needs to be the design variables file that we created, the dv.txt file. So let's go and select that. Like so. And if we have a look at the parameters tab now, we can see that LS-opt has picked up the outer taper and inner taper parameters from the dv.txt file, which is good. Okay, I also need to add another file to this, which is the model itself. So I'm going to tick extra input files, and then I'm going to add the model file. So I just need to browse for that. And I want this to be the morphing model, so the model that includes the morph definitions. And I'm going to tick parse because I want LS-opt to look in that file and to find any other parameters that are in there. So if I hit parse and have a look at parameters again, we'll see that LS-opt hasn't actually found any other parameters in that model file, when in fact there are two parameters in there, and those are the thickness parameters for our crush tube components. And the reason LS-opt hasn't found those is because this is a user-defined stage and not an LS-DYNA stage, so LS-opt doesn't know to look for star parameter cards. The way to get around this is to go into the model and replace the star parameters with LS-opt parameters instead. So I can do that now in a text editor. So I just edit the model in a text editor. And then I'm going to go down to my parameter cards, which are here. And you can see I've got inner T and outer T for the inner and outer thicknesses. At the moment, they're set to 2. And ordinarily, if this was an LS-DYNA stage, LS-opt would recognize these parameters. But because it's a user-defined stage, it doesn't. So I'm just going to replace these now with LS-opt parameters. So I'm just going to call that inner T and outer T, like so, and they've got the double greater than and less than symbols at the start and end. So I can save this now and close this. Then if I come back into LS-opt, and I'm just going to browse for the file again to reload it. And now if I go to the parameters tab, we'll see that LS-opt has picked up inner T and outer T, as well as the tapers that are in the design variables file. So now it's picked up all of the parameters. So the next thing to set up is the command. And let's go back to a slide to take a look at the format of this command. Okay, so the first part of the command is the path to the primer executable. And next is the input model. To apply morphing from the command line, we use the LS-opt option, like so. And this points to the design variables file, which defines how much morphing to apply via the morph flows. Next, we can add some optional arguments via the LS-opt arg option. And I've got those listed here. One of those could be the output file name. So after Primer has applied the morphing, we can get it to write out a new file with a different name. If you don't put anything in for that, then Primer just overwrites the input file once the morphing has been applied. And then finally, we can add the batch option, and I recommend adding this. And this means that Primer will open, apply the morphing, and exit automatically without any extra input from the user. Okay, so let's try and set this up in LS-opt now. So I'm first going to browse for my Primer executable, and for me, it's just on my C drive in Program Files under OVARP and version 17, like so. Next, I can add the model name, which is just crushtube01 morphing.key. It's worth pointing out that this will be ran inside the stage directory, so I don't need the path to this file, since the command will run where the file exists. So next I need to add the LS-opt option. so that Primer knows to apply morphing. And I need to pass this the design variables file, but I don't want this to be the original file with the parameters in. I want this to be the file where LS-opt has substituted those parameters for values. Now at the moment, this is going to be called user opt imp. I'm going to change that to call it primer so I know exactly where, what stage it's associated with. And then in the command line, I can call that file like so. And then I'm going to add the batch option. So we have everything we need on the command line here, so I don't need to add any extra input file. So I'm going to tick this box here to not add the input file argument because it's already there. Okay, so let's take a moment to just talk over how this stage works. So LS-opt will substitute the parameters in the design variable file and in the model file with values based on the sampling. And it's going to copy these files to the stage directory. And as it does that, it's going to rename the design variables file as primer opt imp. And it's worth noting that it won't rename any extra input files, so the model file keeps the same name. Inside the stage directory, it's then going to execute this command here. And this is going to run primer, apply the morphing, and then it's going to overwrite the model file with the morphing applied. So the model file name has not changed. So this model file in the stage directory will then have the morphing applied and the thickness parameters will have been substituted by LS-opt. So it's ready to run. Okay, so I can click OK now. This stage is ready. Next, I need to set up a copy operation so that the pre-processed model is copied from the primer stage directory to the LS-DYNA stage to be ran. And we can see here that LS-opt has already added a copy file operation. I just need to go and set that up. So if I just add a copy operation here, and the source file, well, that's the model file. We've overwritten that, so that's stayed the same. So I can just paste that into there. And then the destination file, well, I'm just going to call this dynaopt.imp. And this is the file that is ran by the LS-DYNA stage. So this operation is going to copy crushtube01 morphing.key to the LS-DYNA stage and rename it dynaopt.imp. And I can click OK. So finally, I'm going to set up the variable starting values and ranges. So that's in the setup stage. So if I double click on that, we can see that our 4 parameters are in there. So I've already got the inner thickness and outer thickness set up. They were in the original project. And then we've got 2 new variables in here, which is the inner taper and outer taper. At the moment, it's setting these to constant with a value of 0. I want to change that and I want to make those continuous. I'm going to leave the starting value as 0, so essentially no taper is applied to the crush tube. And then I'm going to give those a range of 0 to 25 millimeters. So those morph flows can be executed anywhere between 0 and 25 millimeters. Okay, so the project is now ready to run. Let's take a moment to go over how it all works. So the thickness and taper variables are sampled using the sampling strategy. These are passed into the primer stage, which substitutes the parameters in the design variables and model files with the variable values. Primer then runs and applies the morphing based on the taper parameters that LS-opt has set. The pre-processed models are then copied into the DYNA stage and ran. And here you can see that we're doing optimization using neural network meta models. So a neural network is trained on the inputs and model responses and used to calculate an optimum design. LS-opt will then go around this loop again and again until the termination criteria are reached, and ideally that will be when it's converged on an optimum design. So let's take a quick look at one I ran earlier. Okay, so this one has been run. So I'm going to take a quick look at the parallel coordinates plot to visualize all of the simulations together. And I'm going to click all down in the bottom left here to see all simulations from all iterations. And let's look at the simulations that achieve the highest absorbed energy while satisfying the constraints. So I'm going to use the sliders to set my constraints. So minus 100 for the crush and minus 250,000 for the force. And then I'm going to use the slider at the end here to look at the simulations that absorbed the most energy. So we can see that there are two simulations left on the coordinates plot here. Both of these have some outer taper, and the outer thickness has increased, whereas the inner thickness has decreased slightly. I'm going to click on one of these, and this window will tell me a little bit more about the simulation. If I use this PP icon at the top here, I can navigate quickly to the simulation folder. So I'm going to do that, and then I'm going to drag the D3 plot file into D3 plot to look at the results. Okay, and we can clearly see here that some taper is certainly applied to this model, and I can click play to look at how that model behaves. Okay, so thank you for listening. Please sign up to our newsletter, which is information on our next webinars and training sessions, and we hope to see you next time.